Okay, before I get started, I just wanted to demonstrate this. I want to get this running real quick. So I want to do a factory restart of all variables of everything. So this would basically just give me a clean, blank slate. So reconnect. So this is just a blank Jupyter notebook. I just added the time in here. Now this is a UTC time, but run all. That way it can run in the background while I go over my presentation. Let's see here, minimize. So hello and welcome to my DA 621 project. My name is Richard Young. So this is a picture of my grandmother, Lillian Young, and me when I was a kid, on my first birthday actually. A lot of my youngest memories, my first memories, are of her taking care of me as a kid. I remember her cooking for me. I remember, her loving me. I remember going on vacations to Disneyland and much more. She had a great impact on my life. Well, in my last year of middle school and basically my first year of high school, I moved out to help take care of her. She developed Parkinson's disease. And back then, in the mid-90s, there wasn't a lot that could be done for Parkinson's. There was L-DOPA, but not much else. Not even a lot was known about the disease, the pathology, really anything, the life expectancy or anything. So that's why going to college, I knew instantly, without a doubt, I wanted to help people, and also I wanted to study neurological diseases, or in particular neurodegenerative diseases. Here's a paper I published 4 years ago, on different neurological diseases. This is something that I feel is vitally missing in the world, is a comprehensive understanding of neurological diseases. And it's been great to see in the last 5 years how many advances have been made in Alzheimer's and Parkinson's and everything else like that. So what makes neurodegenerative diseases so difficult to research? And I remember this graph from my undergraduate days. And if you really look at it, let's focus on the blue line. Okay, that's neuronal injury. This is for Alzheimer's, but the same can be said for Parkinson's and some other neurodegenerative diseases. So this is your cognitive normal and healthy. Once in theory you get past this break point or cut point as they call it, there's no turning back. The damage is done and you can't repair it. Now, we're still considered clinically normal, and our brain makes up for these losses, okay? Now we're in what we call MCI, mild cognitive impairment. And one easy way to think of mild cognitive impairment is a sprain. You didn't break your arm, you sprain your arm. Maybe you just have a small crack or fracture. Mild cognitive impairment is just something that, hey, you're slowing down. You have some problems, but we really don't know if it's Parkinson's. We don't know if it's Alzheimer's. We just know there's something not right there. But look at the fold level increase from where you should be or the point of no return. And then once we get down to dementia or Alzheimer's or Parkinson's, the damage is possibly too much to basically repair. Once you've lost those neurons, those memories are gone. That is why looking into drugs that can perturb, slow, alter, anything, this steep curve is vital. Okay? A couple other reasons that neurodegenerative diseases are so difficult to study is we can't physically look at the brain. We can do MRI, but we can't physically see it. If I break my arm, we can see that. If I have inflammation, we can see that in temperature, for example. But neurological diseases don't always express themselves the same way. And by the time that we can definitively, or even, say with, relatively little doubt, you have Parkinson's, you have Alzheimer's, it's too late. So that's why finding drugs that can slow this down is so vital. So the project I picked to work on for the next year, maybe 2 years, is Ndd Drug Matcher. This is a project by Dr. Fonseca and Sam Black and others, Dr. Cummings, to basically look at clinicaltrials.gov. Now, in my mind, the way I think about this is almost in terms of a lay person is a lit review. So a lit review, we look at the corpus of work for publications on a particular topic, and we extract that information and we summarize it. This project is very similar, but we're not looking at research journals. We're looking at clinical trials. So what we want to do is take the clinical trials, aggregate that data, and make it usable, make it presentable, make it impactful. And another reason that I'm so passionate about this project is that it's half neuroscience. I'm a computational neuroscience PhD student, and half data science. And I'm a master's data science or master's data analytics student, both at UNLV. So in my mind, this project fits in my wheelhouse perfectly. I have two domain experts I can work with, one on the clinical side, one on the data science side. It's a great project for me. Another thing is that since I have a little bit of programming experience, I don't necessarily need help learning the syntax of programming, but more the logic of programming. Those grammatical errors versus those contextual errors. There, and there. In programming, it's no different. In programming, I can teach you what a certain function, print, means, but when to use it, how to do logging with it, how to do standard out, those things are a little bit more complicated, and that's really what I need to learn. And one way to do that is pick up projects kind of already developed and kind of review it. Because you really have to do more than just read a function. You have to really understand how it's changing the data. So my goal, and part of this project, is not necessarily just to write code, but more importantly, to really understand the flow of data through the program, to understand how the data is transformed as it moves. Hey, here's a bunch of clinical trials. Then we trim off based on this. Then we revise that data. Then we put hyperlinks in it. And then we filter it this way. That to me is what's vital for me to learn. Okay. Also, since this project is so impactful, I would like to share it with the world. Making it open source is a great idea, but many people aren't going to run it from a terminal. A terminal is a program that CS students, data science, computer people use to execute Python. I want to make this more flexible. In R, there's something called a Shiny app, which we can put on the web, and people that are familiar with R know what Shiny app is. Well, we can use Jupyter notebooks. The advantage of Jupyter Notebook is that it can be run from an iPhone or an Android phone, from any web browser. People in China that don't maybe have access to a terminal can run it. People that don't have a full computer setup and have to install Python, they can still run it on a Jupyter Notebook. As long as they have access to a web browser, they can run this code. They can investigate science. They can push forward and discover new things. And to me, that simple thought is very motivating. So once I got it running in the terminal, I moved it to a notebook, a Jupyter Notebook or a Python iNotebook. And you see it, hey, I got it working, and I wanted to print out some simple graphs. So this is just from the pre-existing corpus of the queries. You see I have Parkinson's about 300, Alzheimer's about 350, okay? And like I said, so this is just, hey, it works. So now I want to try my own validation. I want to try my own data. I want to try Parkinson's, the disease that took my grandmother away from me too early, okay? And again, a lot of this data is not to be trusted 100% because it's just pilot data. I'm still learning. So if we look, here is just focusing down on Parkinson's disease, okay? And you see it went from 350 down to 50 because I kind of filtered a little bit, maybe too heavy. But at least it's working. At least now I can get graphs. Now I can communicate to people, hey, if you have this input, we know that this is the output. So we know that the filtering works. We know that the graphs are working. I can tell you the current phase, which is slightly different than Parkinson's, a lot more in phase 2, okay? I can look at the status of the disease, the clinical trial. Has a clinical trial been completed? Meaning that there's results somewhere I can go look at. Was it terminated? Why was it terminated? We'll get into that in a little bit. Is it recruiting right now for new patients? Has it not yet started recruiting? Is it withdrawn for some type of medical reason? So these graphs to me are very vital. And so that's why I wanted to put these in here. So those are some of the updates. And again, for next semester or for my next thing, these are just my personal goals. I'm sure Dr. Fonseca has his own goals he'd like me to implement. But for me, some of the things that I feel are important is I like to work on mesh terms. So when I type in Parkinson's, it gives me other related terms. I would like to work on a little bit more just drugs and generics. Because if I'm running a clinical trial, I don't want to use another manufacturer's drug name. I'd rather use a generic name, okay? I want to work on a deeper understanding of what does a successful pipeline look like. Does a successful pipeline look like 3 years? Does it look like 8 years? Is it maybe something in the experimental design? Really, to me, this is vital. I want to look at what works and what doesn't work. I want to develop more graphics. People can understand and are motivated by graphics. So putting plots, graphs, barcodes, things like this in the Jupyter Notebook will help other people move that science forward. I want to do, maybe sentiment analysis is not the right word, but I want to look at the results and see if I can extract intelligence. I want to see if I can extract information from the results of completed trials, okay? And also, I really want to validate this. I want to go through each step, each part of the transformation of the data, and validate each step. Any questions? Okay, now I'm just going to switch over for the last minute or so of this presentation to the Jupyter Notebook to ensure that it ran real quick. So here we go. We're back on the Jupyter Notebook, and we see the time. I started at about 10 minutes ago. You see right there, about 10 minutes ago. So again, just did some additional dependencies because of matplotlib and things like this. Some Linux dependencies, and I guess I could just pick one and Zipper and it would work. Then basically, it completely starts fresh. I want to start with a fresh GitHub pull. And I do a pull. I grab the SQL databases, or the data. I shouldn't really call them SQL queries, but the raw data. Unzip it, make the directories, which might not be necessary anymore, need to do some more testing. And then in here, eventually, this is where I like to integrate mesh terms and a little bit more flexibility, where I can just type in a term and it populates this kind of down, okay? But, so basically I load the common.py, which are some of the more common functions that are used later. And basic table structures, the new eligibility checker, I got working, so that you can see that ran just fine. The drug classifier, okay. Some additional, again, filtering, and the main filter right here, basically create blank arrays. Open a file, check to see if it's in there. If not, if it is, append. If not, just drop, basically. Do some basic logging. I mean, this is your code. You probably know more than I do. But, I mean, you see trials with Ndd and title, but not in condition 131. Okay. Drug matching. So, again, additional filtering. This is your code, so I don't need to explain to you. But here's some additional things. Again, the graphs, which will, again, be made better. And also here, I just updated this morning, where I included a download. So, basically, you click here, and it downloads it. Okay, and I think it downloaded already, but then this is, again, I think very valuable for researchers, is to create a zip file. Actually, right there, just downloaded, and then now we have a nice, easy, accessible flat file of the output. Okay, so what we have done, with your project, is I've taken it, made it a web page, and provided the person running the code the output. So, if I can make the input a little bit more interactive, I think this will be very beneficial to a lot of people. So you can see the disease names match. So I don't have to go into the terminal. I don't have to install Python. I literally just have to go to a website. I'm hoping to type in a few diseases. The mesh terms will populate the abbreviation, the related terms, and boom, I'll have results. Again, this is more of a long-term goal, but I hope that I've expressed my desire to make something really accessible to the general public, to other scientists that might be outside the domain of CS. And I look forward to working on this next semester, and thank you for your time.